An operator runs a genuinely well-configured Antidetect browser, a real premium tool, profiles built carefully. An account still gets flagged inside a week. The frustrating part is the browser did its job. Every canvas result was distinct, every font list believable, every profile internally consistent. The browser was never the only thing being read. Underneath it, the proxy was quietly telling a different story, and the mismatch between the two is what actually got the account caught. Quick word on where this is coming from. I run real proxy and cloud phone farms, and pairing a browser fingerprint against the proxy correctly is where I spend most of my actual testing time, more than the browser feature list itself. I'm going to stay defensive and third person the whole way through. How a mismatch gets caught. Not a recipe for beating any one platform. Two stories, one verdict. Here's the frame that makes the rest of this make sense. A platform reads two separate stories about every visitor. There's the device story, everything the browser reports about itself. Canvas, WebGL, fonts, hardware, and there's the network story, everything the connection itself reveals. The IP address, its reputation, its geography. A platform doesn't just read each story in isolation. It checks whether the two agree. A flawless device story, sitting on top of a network story, that contradicts it, is often a bigger red flag than an average, unremarkable setup on both sides. What a mismatch actually looks like. Picture the specific shape of this. A browser profile reports a time zone and a locale consistent with one country, while the proxy is routed through exits from an IP registered in a different one entirely, several time zones away. Or a profile's hardware entropy, the exact pattern of specs and rendering quirks, resembles a data center machine, while the proxy is being sold and priced as residential. Neither half is wrong on its own. Together they're a contradiction, and contradictions are exactly what the two-story check is built to catch. IP reputation as its own signal. It's worth being clear that an IP address carries a reputation entirely independent of anything the browser does. Abuse reports tied to that address, a history of prior account bans associated with it, whether it falls inside a range known to belong to hosting providers or proxy services. All of that gets scored on its own, before a single fingerprint script even runs. A browser can be doing everything right, and still inherit a bad reputation the moment it's routed through an address with a poor history attached to it. The shared and reused proxy problem. A proxy that's reused across many unrelated accounts creates its own version of the same problem an identical browser fingerprint creates. If 100 different, otherwise well-separated profiles all funnel through the same handful of exit addresses, those addresses accumulate a visible pattern of their own, regardless of how distinct each browser fingerprint looks. The network layer relinks what the device layer worked hard to keep apart, because the address itself becomes the thing tying everyone back together. Mobile, residential, and data center. Not all proxies read the same. Not every proxy type carries the same starting reputation, and it's worth understanding why. A mobile carrier address is typically shared by an enormous number of real phones behind the same carrier-grade network address translations. So a single address showing traffic from many different accounts is completely ordinary and expected, not a red flag on its own. A residential address usually maps to one household, so a heavy pattern of unrelated accounts from that same address stands out more. A data center address carries the least trust by default, because ordinary people don't browse from server racks, and detection systems already know it. Matching the fingerprint's implied device type to the proxy type actually being used is its own version of the same consistency problem that runs through everything else here. ASEANs and reverse DNS. What the address itself admits, an IP address carries metadata that has nothing to do with the browser at all. Its autonomous system number reveals which organization owns the block it belongs to, and a quick lookup easily separates a residential ISP's range from a hosting company's. Reverse DNS, the address's own hostname record, often spells out words like server, hosting, or a cloud provider's name directly, handing over the answer before any deeper check runs. A browser profile can be flawless, and still sit behind an address that is, in effect, wearing a name tag that says data center, session churn, and rotating addresses. Some proxy setups rotate the exit address mid-session, switching addresses every few minutes or on every request. That behavior itself is a tell because it doesn't resemble how a real device connects. An ordinary user's connection holds one address for the length of a session, sometimes for days. An address that jumps around constantly, especially in the middle of what's supposed to be one continuous visit, breaks the continuity a real connection would have, and that break is itself a signal worth reading, independent of anything else being checked. Time zone, locale, and language specifics. This deserves calling out on its own because it's the fastest mismatch to catch of everything on this list. It needs no active fingerprinting script running at all, just a plain comparison between the browser's reported time zone and locale and the geography of the exit IP. A browser claiming a language and time zone that doesn't remotely match where its proxy connection is coming from is visible immediately, and it's one of the first checks that gets run precisely because it's so cheap to run. WebTPT is a bypass. WebTPT deserves its own mention here because it operates completely outside the proxy path if it's left unmanaged. It's a feature meant for voice and video calls, and if it isn't properly controlled, it can quietly reveal a real local network address underneath whatever proxy is supposedly handling the connection. This one is unusual because it doesn't create a mismatch between two stories. It leaks a third one entirely, bypassing the careful proxy setup altogether and handing over information the rest of the setup was specifically built to hide. Geolocation API mismatches. Browsers expose a geolocation API that a site can request permission to read, and it doesn't always pull from the same source as the IP address. Some setups report GPS-style coordinates that were set independently of the proxy's actual exit point. And if those coordinates land in a different city or country than the IP's registered location, that's a second separate geography check beyond time zone and locale, one that's easy to overlook because it only triggers when a page actually asks for location permission. TLS fingerprint and proxy interference. One more layer worth knowing because it sits between the browser and the network and can quietly break either story on its own. Some proxy setups intercept and rewrap encrypted traffic in ways that alter the TLS handshake a site actually receives, so the browser's own consistent TLS fingerprint arrives looking like something else entirely by the time it's read. This isn't the browser lying, it's the proxy layer changing the packet on the way past, and it's exactly the kind of contradiction the device story and network story check is built to notice, even though neither the browser nor the proxy alone did anything wrong on its own. Update drift. Setups that worked cleanly for months can start failing for reasons that have nothing to do with anything an operator changed. A browser update shifts default values across an entire profile. A proxy provider reshuffles its address pool and hands out addresses with a different reputation or geography than before. Either one quietly turns a previously consistent profile into a mismatched one. And because nothing about the operator's own setup changed, it's easy to miss that the ground underneath it moved. Signals the fingerprint never touches. Even a perfectly matched device and network story doesn't end the conversation, because platforms read a third category entirely separate from both: behavior, typing rhythm, mouse movement, how quickly actions happen after a page loads, posting cadence, how old an account is, who it interacts with. None of that lives in a fingerprint or a proxy at all. An account with a flawless technical setup that behaves nothing like an ordinary user still gets caught because behavior is being read on its own axis the whole time. Again, the warm-up mismatch. Behavior gets more specific than just typing rhythm and mouse movement. A brand new account, hours old, immediately performing the volume and pace of activity a genuinely established account might, is its own mismatch, this time between account history and account behavior rather than device and network. Platforms weigh how old an account is against what it's doing, and a mismatch there catches setups that got every technical layer right but skip the slow, ordinary warm-up a real new user actually goes through. How an operator defensively audits a setup. The practical version of all this is a short checklist, not a mystery. Does the browser's reported time zones and locale match the exit IP's actual geography? Does the IP's registered type, residential, mobile, hosting, match what the profile's hardware entropy resembles? Does the address stay stable for the length of a session instead of rotating mid-visit? Is weird PT actually locked down rather than just labeled as blocked? Running through those 4 questions before trusting a profile with an account that matters catches the overwhelming majority of the mismatches described here. Checking the network side, not just the fingerprint side. Testing a browser's own fingerprint on a public entropy checker, the kind of tool worth running before trusting any profile, only covers half the audit. The other half is checking what the proxy itself admits, independent of the browser entirely. Public IP reputation and geolocation lookup tools exist for exactly this. They report an address's registered location, its ASN and organization, and often flag it outright as residential, mobile, hosting, or a known proxy. Running a proxy through one of these before pairing it with a profile catches a mismatch before an account ever gets created on top of it rather than after. The false sense of security. A genuinely good Antidetect browser can create its own kind of overconfidence. Once every canvas result, every font list, every hardware value checks out, it's tempting to treat the setup as finished and stop looking at the proxy at all, treating the browser's polish as proof the whole identity is solid. But the 2 stories get graded separately and then compared, and a platform doesn't care how much work went into the half that turned out fine. The mismatch is what gets flagged, not the effort, and an excellent browser doesn't buy back a proxy that quietly contradicts it. The honest limit and the honest ending here matters more than the checklist. No browser and proxy pairing, however carefully matched, guarantees an account survives. It removes one specific class of mismatch, the contradiction between a device story and the network story. It does nothing about behavior, nothing about account age, nothing about how a platform's detection quietly shifts over time. Anyone selling a pairing as a guarantee against ever getting flagged is promising something no technical setup can actually deliver. Which browser and proxy combinations actually held together under real testing, and which ones quietly contradicted each other, is written up at antidetectreview.org. Tested hands-on, no undetectable promises anywhere in it. If this explains something that's been happening to you, subscribe, because next up I'm walking through one real mismatch end-to-end and exactly which signal gave it away. See you in the next one.